Okay, let me show you a couple of examples and then I could connect differentiation and integration here. So for example, the y is, let me take the complicated one. Let's say like 3x, sorry, not 3x, I mean like sine, let's say 4x minus 5. So still simple. So then let's say here the dy dx, this will be 3 stays because it's a number, right? So then we can just like kind of ignore it. Then remember, what is the differentiation of sine? So it goes with cos. So then we go with the outer part, which is the sine first, but the one stays inside. Just keep it. Then chain rule, they're connected, so that's why you multiply with the inside part. So you derive it once again. 4x minus 5, if you differentiate, you got 4. So you get 12 cos 4x minus 5. Now if we try to do it backward, let me use the right. So if we try to do it backward, for example, integration of 12 cos 4x minus 5 dx. So what do we do? Our answer should be this, but then like procedure wise, then what do we do? Because it's 12 numbers, so then we can just keep it, just like the 3, we just keep it. Cos, if we integrate cos, that will be a sine. So then same thing actually, like sine 4x minus 5. But then we know before that there's this chain rule thing, right? So then that's why the number are actually different, 3 and 12. So then how do we get the 3? So actually it comes from the 4 here. So that's why they call it like the anti chain rule or reverse chain rule or whatever it is. So over 4, that's why then you will get 3 sine 4x minus 5 plus c, definitely plus c. So you see that the 4 comes because of chain rule, and this works only for this kind of simple type. So if you work on with the more complicated one, for example, like integration of, for example, cos x squared plus 2 dx, this is not covered now. It's still what the topic will be in further calculus, so it's still later. So then for now, it's just like the more simple type of function, so then we can just ignore this. Okay, so let's see another example. Okay, for example, we have, now we go with, let's say e. Let's say we have 10e minus 2x plus 5. Plus 5, my writing is awful. Okay, so the dy dx here will be, keep it 10, and then we know e, just go with e again, right? So then the e power of negative 2x plus 5, but then the chain rule, so then you times it or you multiply with 2, negative 2, because there's the negative 2x plus 5. So then we have negative 20 e power of negative 2x plus 5. And then if we check the integration, if we do it backward, we give another color. Integration of negative 20 e power of negative 2x plus 5 dx. So just the same thing like before, keep it the negative 20, and also this, keep it exactly the same, but then there's the reverse chain rule once again. So then times, instead of times negative 2, but because it's a reverse, and then we do it like negative half, and then plus c. So then we have 10e negative 2x plus 5 plus c. Basically, it's the idea of integration is just, not just, but it's like this. So then, like what I said before, you have to be very good at differentiation before you can actually really understand integration, because they're just the reverse. But then in the more complicated examples, like in more challenging ones, it's not easy to see that anymore. So then sometimes if we want, even if we want to try to differentiate it, to check our answer, whether our answer is correct, actually the form is not the same anymore. But as long as we understand it, we get the method, and it does make sense for us, then it's all good.